Hi friends, in this problem we have to solve this equation x square minus absolute value of x plus 2 plus x greater than 0 for what all real values of x this equation is satisfied. This is combination of two quadratic equations. We have an absolute value of x plus 2. We know absolute value of something is x plus 2. Absolute value of x plus 2 will be x plus 2 if x plus 2 is greater than 0, greater than or equal to 0, or if it is a negative number, it is again minus of x plus 2, right? So let us break this into two quadratic equations. Basis x plus 2 is greater than or equal to 0 or x plus 2 is less than 0, and solve both the quadratic equations and then find out what are the values of x that will satisfy this, right guys? Now, when x plus 2 is greater than or equal to 0, what will this become? Absolute value of x plus 2 will be x plus 2. So, this equation will simplify to x square minus x plus 2 plus x. Right, that means this minus x, this plus x and minus x will cancel. X square minus 2 should be greater than 0. That means x should be greater than root 2 or x should be less than minus root 2. Right. At the same time, x is by originally, because x plus 2 is greater than or equal to 0, that means x should be greater than or equal to minus 2. Okay, so x greater than or equal to minus 2. What are our conditions? X greater than or equal to minus 2 and x less than minus root 2, or x greater than root 2. That means x is lying between minus 2 to minus root 2. This is open end because x is less than. Here it is not less than or equal to, it is less than. Whereas x is greater than or equal to minus 2. So that's why it is closed bracket and it is open bracket here. Union x greater than root 2. That means root 2 to infinity. Okay. As long as x plus 2 is greater than or equal to 0. Now when x plus 2 is less than 0, what will happen? Then modulus of when x plus 2 is less than 0, modulus of x plus 2 will be equal to minus of x plus 2. Right. For example, when x plus 2 is, let's say, minus 4, then modulus of minus 4 is minus of minus 4, okay, which is equal to plus 4. So that's why minus of x plus 2. Now x square minus of x plus 2. X square minus of x plus 2. This means x square plus x plus 2. Right. If an x module absolute value of x plus 2 is minus of x plus 2, this minus and this minus will cancel. We will be left with x square plus x plus 2 plus x is greater than 0. What does that mean? X square plus 2x plus 2 is greater than 0. Right. We know this equation x square plus 2x plus 2. The determinant is less than 0. B square minus 4ac. Right. 4 minus 4 to 8, which is minus 4. Determinant is less than 0. That means this equation doesn't have real roots. It has complex roots. Okay. And the coefficient of x square is positive. That means the graph will look something like this. It will not touch x-axis. Right. It will be facing upwards. Why? Coefficient is coefficient is positive. At the same time, determinant is negative. That's why the graph will face upwards. If the coefficient was negative, then the graph would have been like this. Right. If the coefficient of x square would have been like this, then graph would be facing downwards. Right. Now, this is one way. Another way is what? This equation we can write it as x square plus 2x plus 1 plus 1. Okay, which is nothing but x plus 1 whole square plus 1. Right. That means this is always greater than 0 for whatever x, because this is a perfect square plus 1. Whatever x you take, it is always greater than 0 and the lowest point would be 1 when x equal to minus 1. Okay, this is the vertex of this graph. When x equals minus 1, this becomes 0. This is the lowest point, that is this 1. Okay, so both graphically and algebraically, we realize that this equation is always greater than 0 whatever x. But whatever x is not the one we are looking for. We are concerned about, first of all, this equation will come when only one x plus 2 is less than 0. That means x is less than or equal to minus 2. Okay, so this equation is what, first of all, this equation is valid only for the cases where x is less than or equal to minus 2. That means in this case, any x is possible, but in this case x is less than or equal to minus 2 means the value of x can be anything less than minus 2. Okay, minus infinity to minus 2. So what is our question? The question is, for what values of x this equation is true? When x plus 2 is less than 0, any value of x is fine. When x plus 2 is less than 0, that means x less than 0, any value is fine. When x is greater than when x is less than minus 2, anything is fine. When x is greater than minus 2, then minus 2 to minus root 2 and root 2 to infinity. Right, when x is greater than minus 2. So basically, what is our total set? Minus infinity to minus 2 and minus 2 to 2 minus root 2. What does that mean? Minus infinity to minus root 2. We can make this open brackets. Okay, so minus 2 to minus root 2 is here, minus infinity to minus 2 is here. So total this and this together we can write it as minus infinity to minus root 2, union root 2 to infinity. So this is the range of x which will satisfy this inequality. Right, guys? So this is the correct answer. Minus infinity to minus root 2 and root 2 to root 2 to infinity. Right, guys? Hope you like this. Thank you.